Yeah, good evening everyone. In the last videos, we covered very clearly about N-Queen's problem and we struggled like anything to understand that concept. Finally, from your point of view, you have given conclusion that this N-Queen's problem is very simple if we understand this logic. Now we have two more concepts are there. Of course, one concept only, that is a Sudoku problem. We will solve this Sudoku problem. But before moving to this, there is one small recursion based problem is there. I want to talk about this. What is this problem? Grid ways. It is a small problem, sir. We have to find the number of ways. We have to find the number of ways to reach from a grid. Grid means something like a matrix from 0 comma 0 to m minus 1 comma n minus 1 in a m by n grid. Grid means, sir, I can say it is nothing but something like a matrix. We have m by n grid is there. So we have to find how many ways are there to reach from beginning of the node to ending of the node. For your understanding purpose, I am taking a 3 by 3 grid. Okay, this is nothing but a 3 by 3 grid. Means what? How many rows are there here? We have 3 rows are there. How many columns are there? We have 3 columns are there here. And coming to the locations, this is 0th location, this is 0th location, this is the first location, this is second location, first location, second location. This is the starting point, sir. Okay, 0 comma 0 from here to, so we have to move up to here, 2 comma 2. So we have to move from this particular position to this particular position. How many ways are there? We have to find out. Sir, by seeing this, you may have a confusion, but make sure there is one constraint is there here, where we can move only in left direction. We can move only in left direction and down direction. These are the two directions that we have to move. Now you need to find how many possible ways are there. Sir, maybe the problem is very big for you to understand. To understand very clearly, I am going to take only one grid, simple grid, only one grid I am trying to take. Consider it is 0th row, 0th column. So from this particular position to this particular position, how many ways are there? I need to move from here to here. Only one way is there, right? Okay, to move from this particular position to this particular position, we have one way is there. Listen careful. Now, sir, I have a 2 by 2 grid is there. A 2 by 2 grid is there means what? Here we have two rows are there and two columns are there. I need to identify how many ways are there. Okay, 0th location, first location, 0th location, first location. This is 0 comma 0 and this is 1 comma 1. How many ways are there? First possibility. So first we will find from here to here how many ways will be there. From here to here how many ways are there? One way is there. Okay, from here to here we have how many ways are there? One way is there. From here to here how many ways will be there? One way. Okay, so that from here to here we are going to get two ways. Sir, how you are getting this? Very simple. Is the two ways is there correct or not? Let us cross check. We have a grid like this. What is the first way? From this location to this location, one way. From this location to this location, one way. This is the first path. From here to here we can move. From here to here we can move. This is the second path. Total how many ways are there to reach to the ending? Two ways are there. Sir, it is nothing but, yes, this particular problem is divided into individual subsets. Here you can able to see when you have only single element in the grid, from that location to that location, it requires one unit because one step. So if you want to come from this particular position, how many ways will be there? Only one possibility is there, because you can move in the left direction or you can move in the down direction. We can't move from the left because out of the range. The only possibility is nothing but you can come to down. This is one way. From here to here also we have only one possibility. Okay, we can't move down. So from here to here one way, from here to here one way. That sum is nothing but whatever you are getting. So these many ways are there to move from this particular location. Sir, at least if some understanding if you got, then I will go to this 3 by 3 matrix. Can you please confirm everyone? Is this particular grid based problem, is it clear for you people?
Yes, sir. I have a little doubt regarding direction. That is, the left direction means in the
no. I think it is right direction.
right direction. Actually.
Yeah, thank you. It is right direction. Sorry. Sir, is it clear up to this? Please confirm
Yes, sir,
everyone. I request everyone to please confirm. Because why we have given these directions means you can imagine. If you see this location, there is only two possible ways are there. One, we can move in this style or in this style. That's why these are the two directions which they have given. Right. Now, observe carefully. We need to find how many paths will be there from here. See, from here to here, it will take one possible way is there. So from this location to this location, one possibility. From this location to this location, one possibility. Already we calculated. So how many possibilities will be there from here? Two possibilities. Now see here, to move from this location to this location, how many possible ways will be there? Only one, sir. Because only in the right direction you can move. You can't move down direction. From here, how many directions you can take? We can't go for right. We can go only down. That is only one way. Sir, from here one, this particular sum plus this particular sum, three ways are there to. Means what? I'm just drawing for your understanding purpose with brightness. Have a look once. Three. How you are going to get it? This is one direction. This is another direction. Can I come here and can I go down? Can I reach here? So total how many ways are there? Three ways are there. Three ways are there. Okay. Sir, okay, fine. It is very clear. From here also, how many ways? 2 plus 1. 3 ways will be there. If you want, I will draw with dark color, you can see. Okay. So from here, it can move here and then from here to here, one way. Okay. From here, I can able to move here. Okay. Yeah, 1 second. Yeah. So here you can able to see it is moving. This is one direction. Second one is what? From here to here, it will one direction. What is another way? So from here to here and from here to here and from here to here. So total how many ways are there? Three ways are there. That's all right. Now, sir, I want a final answer. What is the final answer here? You can imagine from here to here, how many ways will be there? Definitely you are going to get how many ways? 6 ways. If you want, just I will try to draw, but just imagine. This is one way. This is the second way. Okay. This is nothing but third way. This is nothing but fourth way. This is nothing but fifth way. This is nothing but sixth way. So 1, 2, 3, 4, 5, 6 ways are there. To reach from source to destination, these many possible ways are there. This one you have to calculate by using recursion, sir. Okay, this one we have to calculate by using recursion. I think the problem statement and how you can able to solve this, it is very clear for you people. I think so, right? Can you please confirm everyone, is the concept is clear?
Sir, in this problem, the approach is from ending we are going up to starting point.
We will write algorithm for that because it is a recursive process, right?
Yes, sir. Yes, sir.
So that starting point that ending point will become base case. We will move from the starting point only.
Okay, okay, sir.
Okay.
Okay.
Right. So let us see how you can able to work with this. Let us see how you can able to work with this. So now we are going to implement a program for this. Have a look once. So I'm defining n value as a 3, otherwise n value as a 2, m value as a 2. Now I want to find out to print. So grid ways, how many ways are there? So from 0, 0th location to m, n. Okay, m, n. How many ways are there? We need to define a function called grid ways, which will take 0, 0 means considering I, j and m, n. Okay. Sir, now I'm checking if the value of I is equal to n minus 1 and the value of j is equal to m minus 1. We are returning 1. Means we reach to the end. We reach to the end. Suppose if you take a grid like this, so with 3 by 3 elements, I mean 3 by 3, if you take like this. So what are the locations we have? 0th location, first location, second location, 0th location, first location, second location. Assume here also I will change the values. Now you can able to see this is the starting point 0, 0 and this is the ending point. If I value is reached to n minus 1, what is the n value? It is nothing but 3. What is the m value? It is nothing but 3. So if it is reached to 3 minus 1, 2, 2, this location is 2, 2. If it is reached to 2, 2, then what is the meaning? We have only one solution is there. Then we have one more base condition is there. If I is equal to n, okay, if I is equal to m, okay, or if j is equal to n, okay, if I is equal to m or j is equal to n, what is the meaning? M is nothing but what? 3. If you are reached to third row or if you are reached to third column, then we are crossing the grid and it is going to return 0 as the result. Otherwise, we have to consider value 1 is equal to, we are calling this grid ways. How many solutions are there for this particular point? We have to identify how many solutions are there in this point and then in this point. So how you are going to get the next value? Can I increase the I value by 1 unit and I will keep j value as it is and then m, n. So second value, I will keep I value as it is. I am incrementing the j value. We can say these two values sum is nothing but my result, right? Yes, because previously we have taken like this. But how you are getting this value sum plus this value sum? How you are getting this value sum? How you are getting this value plus this value sum? How you are getting this value sum? How you are getting this value once base condition is reached? Have you observed like everything is depending on this? That's all, concept completed. Here we are not using any backtracking. Simply we are going to check a small problem with recursion. So I am running the program. You can see how many ways are there to reach from 0, 0 to 3, 3 by using this grid. total 6 ways are there. I think a small problem, sir, not required to put more concentration. I think the concept is very clear for you people. So clear up to this, please confirm everyone. Sir, please respond.
Sir, can you please explain the function for m and n equal to 2 for function?
Sir, when m is equal to when m is equal to 2 and when n is equal to 2, what will happen? First time I value is nothing but 0 comma 0. Is it equal to m and then n? No. So we are going to call grid ways in two ways. What is the first way? I plus 1, 1 comma 0 comma m value is 2, n value is 2. What is another call? 0 comma 1 comma 2 comma 2, because j plus 1. Again it will be calculated for 1 plus 1, 2 comma 0 will be there, and here 1 comma 0 plus 1, 1, and here it is going to get for 0 comma 2, and this will come for sorry, first I think it will come for 1 comma 1, because I value we are increasing. Next we are increasing j value, like this we are getting. Okay, now what will happen? So every time you have to check whether I or j reach it to n. Here I is reached to n, that means we have to return 0. This value is 0. Here is I is equal to 2 and j is equal to 2. No, then I is equal to m minus 1. I value is 1. Is it equal to m minus 1? Is 2 minus 1, 1 only. And j value is also 1. Then it will return 1. These two sum we are calculating. Who called them? For them we are returning 1. In this case also it will return 1. In this case it will return 0. 0 plus 1 will become 1. So this sum is nothing but what? 2. So two ways are there since we are using 2 by 2. Correct, right? Got it, sir?
Yes, sir.
How base condition is decided first? Because just now we have seen when we have solved with one grid, what will be the result? That is the base. Because when we are starting from the beginning location, when you reach to the end, where it will stop, that is the base condition. Here there are two base conditions are there. Once if you have only one grid, and the second one is when we are going beyond the boundaries, what will happen? Okay, right. So the next last problem in this backtracking is nothing but very, very important Sudoku problem. I think majority of you students know very well about Sudoku. Now we are going to see how we are going to implement this Sudoku. Sir, it is a very simple algorithm. I will demonstrate with the help of one simple example. Have a look once. Sir, first I will take Sudoku. I will take Sudoku. You know Sudoku means how it will be. If you want, just let me have a look once. This is the Sudoku official website. So this is one Sudoku is there with me. Okay, so we have to solve this. Okay, time taken is nothing but it will take some time. I will pass this time. No, it is not possible. Okay, we will take these numbers. Have you observed? It is a 3 by 3 matrix. Okay, it is a sorry, it is a 9 by 9 grid, sir. In this, what constraints are there? Every box is filled with a number such that in the single row, whatever digits you are taking, 1 to 9 you have to take. No digit should be collide with each other, same like n-pins problem. Suppose if you are trying to take, first try to start with 1. Is one digit is there in the row? No. Then we can place. Second condition, that one digit is not there in the column also we have to check. It is not there. Third constraint, sir, that one should not be there in the grid also. Have you observed? The grid is nothing but what? This one. Oh, the number got changed. Okay, don't worry. Here, if you try with 1, one is not there in the row, one is not there in the column, and one is not there in the grid also. We can take. So I will take one. Next, so it is a mistake actually, because one should not come here. So because there may be a problem, we will see how it is worked. So can we take 2 here? In the row 2 is not there, in the column 2 is not there, we can take. So here, can we take 1? Already it is there. Can we take 2? Already it is there. Can I take 3? In the same row 3 is there. So we can't take. Can I take 4? In the same row 4 is there. We can't take. Can I take 5? In the row it is not there. In the column it is there. Can I take 6? In the row it is there. We can't take. Can I take 7? In the row it is not there. In the column it is not there. In the grid also not there. We can take. Like this, we have to check. In a 9 by 9 matrix, every row should contain unique values from 9 to 1 to 9 in any position. Every column should have 1 to 9 in any position. Once if you take a grid, 3 by 3 grid, that 3 by 3 grid should have 1 to 9 numbers in any position, such that no two numbers should collide with each other, means no two numbers should be same. Unique values you have to distribute. That is the concept of Sudoku what we have. Sir, I think a majority of you people know very well about Sudoku. If you are clear with this Sudoku, then I will try to solve this problem. Clear?
Yes, sir.
So I'm going for a new game. Now, so you can able to see here. I'm going, sir, please respond, sir. Your response is very, very important. So here I am taking a 9 by 9, a 9 by 9 grid. So in every row, how many values will be there? 9 values, 4, 5, 6, 7, 8, 9. This is the first row, second row, third row, fourth row, fifth row, sixth row, seventh row, eighth row, ninth row. That's all. So like this, I have a Sudoku is there. Try to fill these values. So in the first row, 0, 0, 0, 3 zeros, 4. In fifth position, 0, 0, 0, 4, 5, 0, 0, 0, 0. Here we have to take which number? So 6 and the next number is 8. So next last number is 3. Next 6 is there here. So next here 197 is there. 1, 9 and then 7. Next 2, 5. 2 and then 5. In the next row, 9 should be there. 5 should be there. And then 3 should be there. Next and after that 6, 8 and then 7. So next in the next row, so first one is 0, second one is nothing but 5, and the last one is nothing but 3, 8 and then 9. So next, so we have to take 3. Next and after that 8 we have to take. Sir, please identify the positions. That row is empty now. In the next row we are taking 9, 6. So 9 and then I am taking 6 here. And then I am taking 3 and then 4. Okay, so in the next row, in the middle, we have to take a 3. So next 6, 8, 6 and then 8. Then at last, we have to take 9. So in the 8th row, we have to take 5. And then we have to take 7, 3. So 7 and then 3. Next 1, 2. 1 and then 2. So in the next row, 7 and then we have to take 4. Then I am taking 2 and then I am taking 1. That's all. This is nothing but the Sudoku what we have, sir. We have to solve this Sudoku. So like our previous program, just I am trying to implement a program called so print Sudoku, which will take the given Sudoku. I am going to print this Sudoku. And I will define one more function like Sudoku solver. Sudoku solver, where I will pass my Sudoku as the input, and from which location we have to start putting the digits 0, 0. If a solution is there, I am trying to print the message saying solution existed. Okay, solution existed, and I'm going to print that Sudoku which we got. That is nothing but result. Sudoku we are trying to print, which is nothing but our result. Suppose if this condition is not satisfied, we are printing the message saying Sudoku solution is not existed, solution not existed. So we have a Sudoku is there. First, initially, before solving that Sudoku, we are trying to print, and we will write a function called Sudoku solver, which will take this Sudoku 9 by 9 grid and starting position as a 0, 0. We will search all possible cases. If a solution is available, it will return true. Then we are going to print a message saying solution existed, and then that solution we are going to print. Otherwise, the solution is not existed. Maximum, you will get only one possible solution, sir. Now, for this, I am going to define print Sudoku function, which will take Sudoku, and we have to print this Sudoku. How we are printing? For each I value in the range of length of Sudoku I am taking, that is nothing but 9. And for each j value in the range of length of Sudoku I am taking, which is nothing but 9. So print, I am printing Sudoku of ij. Okay, Sudoku of ij. So comma end is equal to space. So after printing every row, I am printing an empty line. So just I will check whether it is working or not. I will put this in comments because the function is not yet defined. Now you can see, this is my initial Sudoku what we have. Now we have to fill that zeros with a proper values. That my Sudoku solver function is going to take care how it is going to be provide solution. I request everyone to please confirm is the basic functions whatever we have defined. Is it clear for everyone?
Yes, sir.
Yes.
Right, please respond. Now we have to write two more functions. The first function is nothing but Sudoku solver, where I am taking a Sudoku as an input, and I am going to take a row value and followed by column value. So first I will check whether your row value is reached to 9 and your column value is reached to 0. If row value is equal to 9 and the column value is equal to 0 means what? We came next to this row. That is after 0 we are trying. That means we filled all these values and we came here. We filled this value also. Next row will become 9. Because if you count from 0, 0, 1, 2, 3, 4, 5, 6. Okay, 6. So 7, 8, 9. So sorry, 7, 8. After completion of this, the row value will become 8 means what? We got the solution. I mean, row value become 9 means we got the solution. Their column value will become 0. Then what we are going to do? Yes, there is a solution. Okay. Now, sir, while calculating, sometimes I need to transfer the control to next row. How you are going to write, how you can able to transfer to the next row? We are going to write the message saying next row is equal to row. Next row is equal to row. Sir, next we are going to take next column is equal to column plus 1. I will explain how this next row and the next column is going to be utilized. So as of now, next row means a current row. Next column means transferring the control to next column. Suppose if the next column value, okay, sorry, if the column value is reached to 9, if the column value is reached to 9, so sorry, column value plus 1 is it reached to 9 means what? We transferred the entire row. At last we are in the position. then you have to shift the column value to the beginning or not? Yes. In such cases, I am taking next row is equal to already available row plus 1, and next column will become 0. Generally, next row is the same row, next column will become column plus 1. Suppose if the column value is reached to 9, column value 8 plus 1, if it is reached to 9, then I am transferring the control to next row and the column value will become 0. Okay. And if Sudoku solver, okay, if Sudoku of what we are going to do here, if Sudoku of, one second. Right. So if Sudoku of row I am taking and a column I am taking, if it is not equal to 0, then we are going to return Sudoku solver of, listen carefully. We are transferring the control Sudoku solver of, I am passing Sudoku, and then next row we are passing, and then next column we are passing. Sir, what is this one? It is very, very important step. So consider I was in Sudoku solver. I am trying to fill the columns and rows one by one. I started filling the data here. Unfortunately, in my Sudoku problem, they have given something like this. Something like this they have given. So we have to fill this. Assume I have written some algorithm and I filled this data. Then what will be the next row, sir? Next row is row only. That is 0th row only. Okay. So what will be the next column? Column plus 1. That is nothing but 1. Now this location is 0, 0, but this location is 0, 1. We are in the same row. Okay. We are in the same row. Right. You can see I'm taking 0, 1. So next row will become same row number only. Next column will become column plus 1. We are verifying here. Now check the condition. For this only I have written this. If Sudoku of row value is what? 0. Column value is what? 1. Is this 0, 1? Is it not equal to 0? Yes, it is not equal to 0. We are not required to place any number here. So we have to get the location of this one. What is that location? Written. Again, try to solve the Sudoku solver by passing next row. What is the next row value? Next row value will become row, same row. Next column will become column plus 1. So what is the existing column? That is nothing but 1. 1 plus 1 will become 2. Now check. Is column value plus 1 is equal to 9? No. Then next row will become, next row position will become 0 and then 2 plus 1, 3. Keep this in mind. Now I am checking Sudoku of row. What is the current row? 0. What is the current column? 2. 0, 2. Is the value is not equal to 0? Yes. That means this value is also we are not required to compute. So we will transfer the control to Sudoku solver by passing Sudoku next row. Next row will become 0. Okay, next column will become 3. Now next row, after this what we have to get? Next row will become 0, next column will become 4. Then is column plus 1 is equal to 9? No. Then Sudoku of row value. What is the row value here? 0. Column value, it is nothing but 3. Is 0 comma 3 is not equal to 0? No, it is equal to 0. Now we have to write code here for solving the solution. What we have to do? For each digit in the range of 1 to, I am taking 10, because we have to place the digits from 1 to 9 only. That we have to write here. Don't worry, I will write the algorithm. It is very simple. Whatever we have seen in our previous program, that is nqueens, same situation will be there here. Don't worry at all. Now consider a situation where I was in 0 comma 9. My row value is 0 and the column value is nothing but something like 7. Column value is nothing but or something like 8. That means almost we are at the last position. What will be the next row? Row will become 0. What will be the next column? Column plus 1. That is nothing but 9. Now we are checking. Is column plus 1 is equal to 9? No. When we are at row is equal to 8 itself, we are in the last position. So when we are in the row itself is the last position. Is column plus 1 is equal to 9? 8 plus 1 is equal to 9. Yes, it is 9 only. Then what we are checking? Next row will become row plus 1. So please update this to row plus 1. What is the row value? 0. 0 plus 1 means 1. What is the next column? 0. Please update this to 0, because in the 0th row all the fields got completed. Now we are transferring the control to next line. We are going to check in the next row. So almost the task got finished, sir. Now we have few lines of code is there. Can you please confirm? Is it clear up to this?
Sir, for base condition at line 2, I think column should also be 9.
No,
Column equal to 9.
no. It is not a grid. See, we are in 8 by 8 matrix size, right? 9 by 9. So if you take the last steps, so this will become which column? 8th column, right? 8th row, right? And this will become 8th column. Is it correct?
Yes, sir.
What is the position of this? Is it 8 comma 7 or not?
Yes, sir.
This one is
8
8
comma
comma
8.
8. Next position will come in the beginning, 9 comma 0, because it is a matrix, right? Something like this. So after completion of every row, column value will become 9, means we are shifting to 0. It will start in this row. Once if the row completed, next row beginning. Once if it is completed, next row beginning. Like if you finish 8th row, then where it will come? 9th row beginning. Beginning value will be always row number is 9, column number is 0. Got it?
Yes, sir. Yes, sir. Got it clear.
Please respond everyone. Is it clear
Sir,
up to this?
Sir, so for the column, we can also write 8. It will be fine or not? For base condition, row equal to 9 we have written. Can we write column equal to 8? So
sir, how it will come there? I'm talking about, you are not understanding my point.
Yes, sir. Yes, sir. Got it. Next
Because,
column is value is equal to 9.
Here we are coming 8 comma 8 means next immediate calculation will become 9 comma 0.
Sir,
Yes, sir. Yes, sir. Got it.
How it will come for 9 comma 8 or 9 comma 9? It won't come up to this because it is only 9 by 9 matrix. So if you count from 0, 0 to 8 will be there, 0 to 8 columns, 0 to 8 rows will be there. It won't come with 9 comma 9 means invalid member. So there itself I terminated. But column value also should be checked, right? That's why I have used this one.
Yes, sir. Got it clearly.
You can remove this one also, no problem. With this, nothing will happen. Because anyway, row is equal to 9 means only one possibility is there. You can ignore this, okay?
Yes, sir. Thank you.
Any doubts? Sir, there is no response from you people. In the chart window also, it is empty. Yeah, please, sir. Go ahead.
Index, the 9 is index, right, sir?
9 is not index.
Okay.
Yeah, 9 is index.
So it's a 9 by 9 matrix, 9 by 9 grid, sir. So there can only be eight, right?
That's what I'm checking. Once if it is reached to 9, we got the solution.
Okay, okay.
Got it? If it is coming to 9 means what? You reached the solution.
Yes, sir. Okay.
Okay. Something like termination process. Now I will
So,
implement the program, sir. Yeah.
in sixth line, you can just take it as next column also, right? Or is it like,
No.
because it's
See, generally this will happen only one time. That is when the column reached 8. Okay.
yes.
Till that,
Okay.
next row will become row only. Next column will become column plus 1.
Yeah, but then when it column is 8,
When column
right?
value will become column plus 1. That is, suppose consider, that's what I explained in the diagram. Maybe see, I am talking about the first row. In the first row, we are checking at 0, 7. Assume.
Mhm.
So here row value will become 0, column value will become 7, right? While
Yes.
calculating this itself, we are trying to guess the next row. Next row will become same row. Next column will become what? Column plus 1, that is nothing but 8. Okay. Is column plus 1 will become 9? Majority of people are going to feel this one. No, you have to take this one. Column plus 1. It is not 9. That means we are checking row comma column. Row value is 0, column value is 7. Is there any object is there? If object is there, then we will move to the next row, next column. Consider object is there in both places. What is the next row value? 0. What is the next column value? 8. With this, we are calling again a recursive function. Now, in the next case, row value will become next row and the column value will become next column. Now, we are trying to guess next row. Is the row value reached to 9? No. Column value? No. So, next row will become same row value only, 0. Next column will become column plus 1, 9. Now, we are checking by adding column plus 1, we are getting 9. Yes, by adding column plus 1, we are getting 9. Then your next row will become row plus 1. What is the previous value of row? 0. 0 plus 1. It will be updated. Next column, previously it is 9. Now it will be 0. So 0, 8 we completed. Then what will be the next value? In the second row, first element you have to take. That means 1, 0. We got this 1, 0, right?
Yes.
Clear?
Yes.
Right. Now, sir, I am implementing this one. Let us see. Sir, very simple. We have to write backtracking and we have to write a recursion. Already we have seen this. Is safe function I am going to take. Is safe of Sudoku solver. Is safe of we have to pass only Sudoku and then that row value I am passing, that column value I am passing. We have to place the digit, right? That digit also I am pressing. So if possibility is there, okay, to place that digit, then what will happen? Sudoku of that particular row value and that particular column value I am sending to D. I am assigning to D. If possibility is there, then again I am going to check Sudoku solver. Okay, Sudoku solver of Sudoku I am passing, and then I will pass next row and I will pass next column. Okay, if it is true, then we are going to return true finally. Sir, this is recursion. This is nothing but recursion, but I used a function. After coming out from this recursion, what we have to do? Sudoku of in that particular row, in that particular column. If the solution is not available, try to take 0 and search for another possible digit. When we are getting one digit, if there is any place, then okay. If the one digit is not possible, go to previous and change the previous value and try it for another digit. This is nothing but what I can say backtracking. Okay, backtracking. So at last, this function is going to return false. Because if all these cases are not satisfied, there is no solution. All digits we tried, all the row values, column values I reached, but still the solution is not found, then we are returning false. Because it will keep on moving in the same direction only. There is no possibility means it will return false. This is nothing but what we have about the Sudoku solution. Now what we have to do, you need to write the final code, that is nothing but is safe. So def is safe function I am taking, Sudoku of I am taking row, column, and then digits. So there are three cases are there. What is a case one? Here we can predict. We have to check row wise. Case 2 is what we have to check column wise. So case 3 is what we have to check grid wise. First I am checking row wise. How to check row wise? For each I value in the range of 0, 9, because 0 to 8 rows will be there. Okay, in the row I am checking. So if your Sudoku of I column is equal to D means what? I am going to return false. So if you take a grid, just for your understanding purpose, I am writing the grid here. Something like 8 by 8 grid we have to take. 0th column, first column, second column, third column, so fourth column, fifth column, sixth column, seventh column, and we need to get one more column. Okay, let it be eighth column. Sorry, eighth row. And here 0th row, first row, second row, third row, fourth row, fifth row, sixth row, seventh row, and eighth row. Sorry, columns. So is the numbers are correct? 0, 1, 2, 3, 4, 5, 6, 7, 8. 0, 1, 2, 3, 4, 5, 6, 7, 8. Right. See here. Suppose if I want to take any digit here, what we have to do? In this direction, we have to check. That's what I have done here. We are passing 0, 0, any digit x. So case I, for each I value from 0 to 9. So Sudoku of I value I am changing. That means this position I am changing and this value I am fixing. So if you change this position 0, 0, 1, 0, 2, 0, in this row, if that digit is available, we are returning false. Sir, similarly, we have to check in the column, right? For each I in the range of same 0 to 9. So we are checking Sudoku of, we have to fix the row value and then we are going to take column value. Okay. If it is equal to do, then we are going to return false.
Sir, it should be I think. The numbers.
Uh-huh.
J should be I.
Yeah. Better to take J, because in our normal terminology, we will use I for row and J for column, right? Let it be like that so that we can understand. Okay. Can you please confirm everyone how you are going to check row wise and how you are checking column wise? Is it clear?
Yes, sir.
Right. Now where we have to check in the same grid, is it available or not? Same grid means what? For example, if you take first grid is nothing but this one 3 by 3. So I can say this one is nothing but one more grid. I can say this one is one more grid. This one is one more grid. Like we have multiple grids are there here. 3 by 3, every 3 by 3 matrix. So for that a bit tricky logic I am writing, observe carefully. Starting row will become row by 3 into 3. Like this I am taking row by 3 into 3. So why we have written this, I will explain. So starting column will become column by 3 into 3. So to identify, suppose if you want to check a particular element is there in this grid or not, So this starting value we have to check. How you can check this starting value? Consider the element is available here. What is this position? I can able to say 4 comma 5, right? Now I want to identify what is the starting value of this particular grid. So starting row will become 4 by 3 into 3. This is the standard formula. 4 by 3 means 1. 1 into 3 means 3. Starting column value will become column 5 by 3. So into 3, 5 by 3 means we will get 1 only. 1 into 3 means we will get 3. So 3 comma 3 is nothing but a starting and starting row and column. Is it correct? 3 comma 3. We are going to check in this grid. Suppose if you take any element here, so it is nothing but 7 comma 7. If you take 7 by 3, what is the 7 by 3? 2. 2 into 3 means 6. 6 is the starting location. Column 7 by 3. So same, you will get 6. Like this, if you take any number, if you divide with 3 corresponding row value and corresponding column value, we can touch. So there, if the element is there or not, we have to check. So for each I value in the range of starting row to starting row plus 3 up to 3 locations, because same, right? 3 values will be there in the grid. For each j value in the range of starting column to starting column plus 3. 3 values I am checking. If anywhere that Sudoku of ij contains that digit, then I will return false. At last I am going to return true. That's all, sir. We have verified in the same row is that element is available.
Sir,
The same column it is available. In the grid it is available or not, we verified. Yes, please confirm. Any doubts?
sir, like when we are taking that Sudoku with you have written 0, 0, right? That time we can't take 3 by 3 and we can't separate it like that, sir. Like one function for each 3 by 3 grid.
No, see that element can be available in any position. Okay, suppose if your element is available in this position means what? So in the same row it should not be there. In the same column it should not be there. In the grid also it should not be there. Grid means what? You have to identify in the what I can say here. You can able to see. So they have identified the grid. You can see there is a border is there, right?
Yes, sir.
So in that grid, that number should not be repeated. So in every grid, 1, 2, 3, 4, 5, 6, 7, 8, 9, these numbers only should be there. Repetition won't be there.
Okay, sir.
Got it? Right. So let us run this code, how it is going to work. Almost we came to the finishing, but we need to check whether it will work or not. Let me try. Sir, Sudoku solver is not defined. Where in line number 32?
Spelling mistake.
Line number 32.
Sudoku if su.
So solution is existed. This is the solution which they have given. Let us try to fill that. 4 to 7. I am filling 4. Have you observed? There is no mistake. 4. So 2, 7. Then 5, 6, 8. 5 should be there here. 5, 6, 8. Then 9, 1 should be there here. 9 and then 1. There is no repetition, you can see. So in the next row, 6, 8, 3. 6, 8. So 3. And the last one will become 4. Next here 9, 1. 9, 1, 5. So 3, 1, 9, 7. Okay. 1. Something is wrong. So 9, 1, 5. 9, 1, 5. So 3, 4, 2. Sorry. 3, 4, 2. That is correct. Then in the next row 2, 5, 6. So 2, 5, 6. So next 4, 7, 3. 4 and then 7 and then 3. And in the last row we have to take 1. And in the next 3, 4, 9. 3 already there. 4 and then 9. So next 8, 5, 1. So next 7, 2, 6. 7, 2, 6. So next I am taking 8, 7, 1. 8 7 1. So 9 2 6. Then here 5 is there. So next 1 3 2. So 1 3 2 6 8 5. Next 4 7 9 4 7 9, and then 5 9 8 5 9 8. So 7 3 4. So 1 6 2. So 7 6 4. So 2 1 9, and then 5 3 8 5 3 8. Is it correct solution? Yes, perfect. So this is the solution what we have. That means our program returned correct solution. So try to take another Sudoku and try to trace, because more practice is required in this backtracking. So because you can see, I can't explain everything in the diagram, but you have an option to sit in your home and then try to take the puzzle and then try to trace out one by one and how it is coming. You can do homework on that. Okay, I request everyone to please do that. Okay, so this is nothing but end of backtracking sessions. Okay, next chapter we will go for dynamic programming. Tomorrow there is no class. Next class will be on Monday we are going to start dynamic programming. Okay, right, I will upload these running notes within few minutes. You can download. Thank you friends, good night.
Thank you, sir.
Thank you, sir.